Good evening. Thank you for watching my video. So in today's video, I will get to showing some assembly language code I wrote for my PIC18 MCU. And having said that, you might be wondering why I have the Arduino IDE open. And in specific, I have it open to a sample blink sketch. Well, I thought I would start here. And as I always tell people, I'm still learning. And when I started in microcontrollers, I started out playing around with Arduinos several years ago. So anyway, I have it kind of in my skill set that in C language, when you want to blink an LED or an I/O pin, you send it high, followed by a delay, and then you send it low, followed by a delay, and you just continue to loop that. Of course, in assembly language, it's not that simple. I could have easily used an example on MPLab with C language PIC chip of a similar type of thing, but this proves my point, hopefully. So yeah, this is how I've come to learn as the easiest way to blink an LED. So this is how I wanted to write an assembly program for my PIC chip. But when I went searching on the internet for example assembly language programs for the PIC kit which show the blinking of an LED, there were a lot of different creative ways that people came up with code to achieve the blinking of an LED, but it wasn't always following this type of format. And this is what I've come to know, and I wanted to create my code just like this. So I wrote this program the way I did because it made sense to me. And here I turn port D, but in specific D7, so this particular pin, I turn it high. Then I have a delay, even though it's very complex. It's basically just a delay. And then I send that pin low, followed by a delay. So that's how I wanted to create my code. I am learning this, so I'm kind of stubborn, so I wanted to do it just the same way. Send it high, delay, then send it low, delay. There were a lot of other schemes that people use, like complementing, twos complementing a whole port, and a few other ways. So I'll get to discussing this in more detail here on in. So before the org directive, I created 4 counters. Initially, when I created my program, I didn't have this many counters. I only had 2. But the short explanation is that my counters, just having 2 counters, they weren't long enough of a delay to blink an LED as I decremented them. So I had to add a couple more counters, which added a whole lot more code as well. I'll get to that. So I have 4 counters here. and in the program I'm going to end up decrementing them all. And I loaded them up with the biggest number that would fit in a byte. So 8 ones, 1, 1, 1, 1, 1, 1, 1, 1, and that is 255 in decimal, or FF in hexadecimal. So now this portion of my code is just the setup. So I am setting up the oscillator here, and I'm clearing port D, and I'm making it an output, zeros on all the different bits of port D. My previous video explains all this. So in this first section of actual code, I take all these counters, R1 to R4, which are actually different RAM locations, 25, 26, 27, and 28, and then I just take the equate with the value of 255 in decimal. I put it in the W register, then I load up each one of these RAM locations, which I'm calling R1, 2, 3, and 4, and I'm just loading them all up. So I'm taking the RAM location and putting 255 in all of them. So I'm doing that, just loading them up. So after this completes, or iterates, all of these counters have a decimal value 255 in them. Then I put this binary number here into the W register and load that into port D. The only number I really care about is this first one, the most significant bit. I guess that's D7. I'm just blinking one LED, so I just need one pin. So that's what's going on here, just turning that one pin high. I don't care about the rest. And here's where I start decrementing the counters. So I threw in all these NOPs. I don't know how useful they are, but I put 4 of them in. And then I put a DECFSZ. So decrement the file, which is R1, and skip if 0. So skip the next instruction if R1 decrements down to 0. So the way this works is it goes through one iteration and it decrements 255 to 254. It's not 0, so it goes back up to A2, and it iterates through here 255 times. When it ends up being 0, I load R1 back up again. That's what these two lines do. And then I have an additional counter, which also has 255. So it's going to iterate through everything from here to here 255 times. So there's a loop in a loop, or a nested loop. So it iterates 255 times 255 times. When this additional counter is brought down to 0, it skips this instruction. It skips this instruction once this additional counter loops through and goes down to 0, decrements down to 0. Then it skips this line, and then MOVLW all zeros, make WREG all zeros, and then move WREG into port D, making port D all zeros, basically turning my one D7 pin low. And then much the same as here, I've got another delay. But this uses 2 additional counters, which I have called R2 and R4. R2 at the beginning of the code is loaded up with 255 and goes through one iteration, and it's not 0, it's 254, so it goes through another iteration, 253, keeps cycling through till R2 becomes 0. Once it becomes 0, then R2 is actually loaded up again with 255. That's what these two lines do. And then for 255 more times, this nested loop within a loop iterates 255 times. At which point, when this second counter is decremented to 0, it skips this last instruction and follows this instruction, which is go to A0, which brings it back up to the top and loads up all the counters once again and just continues to cycle through. And it never really reaches the end because it just keeps looping back up to here. So I hope that explains it. I was really proud of this because all day I was actually struggling to copy someone's code I found on the internet as an example of a blink sketch, and I got so frustrated I just said forget it, I'm just going to practice using the knowledge I gained from a textbook I'm reading, and I borrowed from a few different areas of the text and kind of pieced things together and really tried to do things in this style, turning an LED on, delay, turn it off, delay. So I tried to achieve that. Just to give you an idea on how I developed this code, I have a textbook that talks about using DECFSZ, and the textbook also talked in a different section on counters. And hold on. So the following I say is for my own reference. So on page 32 of my text, where it was talking about the instruction COMF, which appears nowhere in my code, it was starting to introduce the go-to statement, which was really creating like forever loops, things that would just repeat forever. So it was once I came across that in my text, combined with the decrement FSZ, which was like page 76 of my text, I kind of combined the two ideas, along with some other parts of the text that talked about counters. So I really drew from a lot of different areas and came up with something that actually worked. I'm surprised I could actually do it. Not that it's hard, but it's hard for me. So thank you very much for watching. Yeah, check out the playlist because there's tons of videos on this particular chip I'm using, which is the PIC18F4525, and there's a playlist on my channel with all videos related to that. Okay, thank you very much for watching. Have a good day.